Okay, now we're about to learn about the difference quotient, which I believe probably this is the first time you guys have ever seen that. This right here is what the difference quotient is. If you think about the name, math people are so boring, they just name things exactly what they mean. So a difference is a subtraction, and a quotient is a derivative, it's a division. So right here we have the difference of two functions, f of x plus h minus f of x divided by h. It's the difference quotient, that's the name of it. What in the world is this thing? It is basically the slope of a secant line. So a secant line is a line that passes through any 2 points on a function. So there's this picture on your worksheet that you have. I'm about to recreate it and kind of explain what the difference quotient is. So if you have some function here, there's a function there, and we have 2 points on this function. So I've called out 2 points right there. Here's the first point, and this is going to be at the value x. This is where x is. And then if we travel a little bit further down the road to this point here, this is how far we traveled down the road. We went h units down the road. So this x value is x plus h. Okay? If you recall the input-output of functions, okay, so here is like input, output, these are our x values. It gets operated on, and what pops out is our y value known as f of x. If we were to put in a different input, x plus h, into our function right here, what we would get out is not f of x, but f of x plus h, right? So right here, f of x, the y value right here is f of x. Right here, x plus h, the y value right here is up here, it's f of x plus h. So we have basically 2 points. This point right here has the x value, x, y value, f of x. That's 1 point. This point right here has the x value, x plus h, and the y value, f of x plus h. That's what we have, just 2 points. Now, if we were to connect the points with a line, that is known as a secant line. It's the line through any 2 points on a graph. So we could draw a line through these. I will try to. If I can't do it, just look at your worksheet. Okay, there's my secant line. What is the difference quotient? The difference quotient is the slope of that line. This is, you know the slope formula? It is rise over run, right? M is rise over run, or the change in the y's over the change in the x's, or y2 minus y1 over x2 minus x1. And where x1 and x2 and y1 and y2, those are points. What if our points, x1, y1, is known as this, x, f of x? And what if our other point, x2, y2, is known as this, x plus y, f of x plus y? And we put that into our slope formula. Then what do we get? y2, f of x plus h, minus y1, f of x, over x2, x plus h, minus x1, which is just x, is this. And look at the denominator here. An x minus an x is just plain old 0. And if we make that simplification, what we're staring at is what is known as the difference quotient. And it is the slope of a secant line. So that is what we're asked to do. Why do we have to learn this? Because many of you will go on to pre-calculus and calculus, and this is the beginning of calculus. So anyway, that's why you're learning it. Right here, let's construct and simplify the difference quotient for each of the given functions. So in our class, if none of this made sense to you, don't worry about it. What you have to do is what we're about to do now, simplifying the functions and constructing the difference quotient. So here we go. Number 1, construct and simplify the difference quotient, this thing right here, for each of the given functions. So we have f of x is equal to x squared minus 3. They will always give you a function. That will be given. What they will not give you is f of x plus h. You have to go figure that out. So let's figure that out. I have to construct this guy. Do you see f of x? That is what this is. I don't have to worry about that. They give me that. I have to figure out what f of x plus h is. So let's do that. F of x plus h is equal to, I replace x with whatever I find there. X plus h squared minus 3. Then I have to multiply this out. X plus h times x plus h is x squared plus 2xh plus h squared minus 3. So all of this right here is what f of x plus h is. Let's construct this guy. Let's construct the difference quotient. F of x plus h is this stuff right here. I don't actually need this parentheses because there's a positive one. So let's write down f of x plus h. X squared plus 2xh plus h squared minus 3. Then I have this minus sign, and it's going to subtract the entire f of x function. I don't have to come up with f of x. They always give that to me, and it's this right here. X squared minus 3. And this is all over h. I just write that down, h. That was the construction part. Now we're just going to simplify this guy. It's very simple. Distribute this -1. Negative times 1 is negative. Negative times negative is positive. Okay, now in the numerator, what do we have that's like terms? We have x squared minus x squared. That's going to add up to a big 0. We have a -3 plus a 3. That's going to add up to a big 0. What is left? 2xh plus h squared over h. We can factor out a h. If you're doing this right, you're going to hit a point somewhere in your problem where everybody in the numerator has a h in the term, and you'll know you're on the right track. Factor out a h, you're left with 2x plus an h over h, and you're going to get this nice cancellation. 2x plus h is the simplified difference quotient for number 1. All right, let's do number 2. It's pretty similar. It's 5x squared plus 4x. We have to construct and simplify the difference quotient for this guy. So let's do that. Number 2. F of x is 5x squared plus 4x. Okay, they give me that. Let's figure out what f of x plus h is. That's where you go in and you substitute in x plus h. Everywhere they gave you an x. So this is x plus h. Now I like to, before I construct this guy, I like to do simplification over here. I just think it's easier. You don't have to do it that way, but that's how I like to do it. So I'm going to square x plus h, which is x squared plus 2xh plus h squared plus 4 times x plus h. Now I'm going to distribute the 5 and the 4. So right here, 5x squared plus 10xh plus 5h squared plus 4x plus 4h. All of that right there is what f of x plus h equals to. Now I'm about to construct the difference quotient. F of x plus h, all of that stuff right there. 5x squared plus 10xh plus 5h squared plus 4x plus 4h, and then minus, by formula, minus f of x. What is f of x? I'm going to subtract the whole thing. F of x is what they gave me, right here. 5x squared plus 4x all over h. Okay, now let's distribute that negative. Negative 1 times 5x squared is negative 5x squared. Negative 1 times 4x becomes a negative 4x. Let's collect like terms in the numerator. What do you see? 5x squared minus 5x squared. This becomes a big 0. 4x minus 4x, that becomes another big 0. What are we left with? Let's factor out a h from our numerator. We have 10xh plus 5x squared plus 4h. Factor out a h, leaving you with 10x plus 5h plus a 4 all over h. These will cancel. This is my simplified difference quotient. That is the answer for that. Okay, we've got 2 more, and I gave us rational functions because sometimes those are a little tricky. So let's make sure we know how to do those. Number 3 is 1 over 2x. We have to do the same thing, only it's a rational function. So let's do 2 more and we'll be done. the same job. Construct and simplify the difference quotient for these two functions. So the first one, number 3 is f of x is 1 divided by 2x. Okay, this is f of x. Let's figure out what f of x plus h is over here. F of x plus h is going to be 1 over 2 times x plus h. You replace that x with x plus h. Let's construct this guy. F of x plus h is this stuff right here. All right, 1 over 2 times x plus h minus, by formula, minus f of x, 1 over 2x, all over h. Okay, we have just constructed the difference quotient. No big deal. Now, we have to simplify it. That is where it kind of sometimes people get confused. There are different ways to simplify this that are equally good and correct. This is just how I like to do it most of the time. This is a complex fraction, and to simplify this complex fraction, I'm going to multiply the numerator and the denominator by the lowest common denominator that I see. I don't really see, h doesn't have a denominator. You just take it over 1. These guys have a denominator. So the lowest common denominator that I can see is, I see a 2, an x plus h, and another x. 2, x plus h, x. If this is going to be a lowest common denominator that this guy could divide into, and separately this guy could divide into. So that is the lowest common denominator. What do I do with that to simplify this complex fraction is I multiply the numerator and the denominator by this. If I want to move the the x over here by the 2, I'm allowed to do that. In fact, I'll just do that. It looks less sloppy. 2x times x plus h is what I got. Now what's going to happen here is, this is legal. I'm multiplying the numerator and the denominator by the same thing. And if you want to see the 1, h over 1, you can write it like that. This will distribute to both of these. So I'm going to write this over here so I can watch it cancel out. All right, ready? 2x times x plus h over 1 times 1 over 2 times x plus h. Well, what's going to happen right here? These 2's will divide out. These x plus h's will cancel out and become 1s. They divide into each other and become a 1. What am I left with? I have a 1 times an x times a 1 times a 1, which is just an x, over a 1 times a 1 times a 1, which is just a 1. I have basically x over 1. That is what goes in this place right here. Here's my minus sign. Minus 1 over 2x times all of this. What's going to happen here? The 2x's will cancel, divide into each other, and become a 1. I'm left with the 1 times x plus h over 1. That's all that's left here. 1 times 1. This is my new numerator. That simplified that a whole lot. In the denominator, nothing cancels out. I just have 2 times x times h times x plus h. That's what I have. Now let's distribute this negative 1. Negative 1 times x is negative x. Negative 1 times h is negative h. X minus x is a big 0. I'm left with a negative h over 2 times x times h times x plus h. What's going to happen is those will cancel. I get a negative 1 over 2x times x plus h. This is the simplified difference quotient. Last one, f of x is negative 5 over 7x. This is number 4. Construct this guy and then simplify him. Okay, let's construct him. F of x plus h is simply negative 5 over 7 times x plus h. All right, so construct it. Negative 5 over 7 times x plus h minus f of x minus negative 5 over 7x all over h. We just constructed the difference quotient. Let's simplify it just a bit. Do you see this negative times a negative? That is really a positive. Let's go ahead and do that. That'll make it a little bit better. All right, then what do we do over here? Well, over here, we multiplied by the lowest common denominator to get rid of our complex fraction. We're going to do the exact same thing. So let's do that. What's the lowest common denominator? I see a 7x and a 7 times I see a 7x, and then I see a 7 times the x plus h. 7x times x plus h is the lowest common denominator because 7 times x plus h can divide into that evenly, and 7x can divide into that evenly, so that's a good one. And multiplying the numerator and the denominator by the same thing. Because this will distribute, I'm going to write it down twice. Over here, what will cancel? We have a 7 and an x plus h, which will divide into a 7 and an x plus h evenly. And we'll just get a 1 for those, right? What's left? A negative 5 times x, negative 5x. All of this mess just turned into a negative 5x. Then we have a plus. 7x goes into 7x. 5 times 1 times x plus h is 5 times x plus h. All over 1. And down here we get 7x, h, x plus h. Nothing canceled. It all got multiplied together. Let's distribute that 5 right there. This becomes 5x plus 5h. Let's collect like terms. Negative 5x plus 5x will give us a big 0. We're left with 5h over 7xh times x plus h. What will cancel here? The h's. Simplify difference quotient in this case is a 5 over a 7x times the x plus h. And that is our simplified difference quotient for that one.